Yes,
Good morning to all of you. I'm here to discuss with you the next topic, that is photoelectric effect and dual nature of matter. Okay, photoelectric effect and dual nature of matter and radiations. The first question, that what is photoelectric effect, what is matter, and what are radiations? Actually, in the universe, there are only two entities. That is, first one, matter, and second, that is radiation. Matter is having four states. The first one, solid state, liquid state, gaseous state, and plasma state. Okay, radiation. Second aspect, that radiations are the stream of photons, or radiation is a form of energy. Matter is what? Matter is four types. That is, first one, solid state, liquid, gaseous, and plasma state. Radiations are the stream of photons. So the first question, what is photon? What is photoelectric effect? Then we have to discuss for experimental setup to study photoelectric effect. Effect of intensity, frequency, potential on photoelectric current. Then graphical representation of variation of photoelectric current. Then laws of photoelectric effect, Einstein's photoelectric equation, variation of laws of photoelectric effect based on Einstein's photoelectric equation. In short, we are going to discuss for applications of photoelectric effect. Then the important point, that is concept of matter waves and the properties of them. And the last point, that is the supportive experiment in order to say the presence of matter waves are there. Okay, so this is the scope for today's lecture. What is photon? Just we have said that matter is available in four different forms. Radiations are also having different forms of energy. Radiation is a stream of photon. Photon is a packet or bundle of energy is called a photon. Packet or bundle of energy is called a photon. Energy of a photon E equals to h mu, that is equals to hc upon lambda. E equals to h mu. That is famous Planck's constant equation, where h is Planck's constant, mu is frequency of radiation or photon, c is speed of light, and lambda is the length. E equals to h mu. Okay. Then what are the properties of photons? A photon travels at a speed of light c. What is the value of c? C is 3 into 10 raised to 8 meter per second. It has zero rest mass, that is, photon cannot exist at rest. Next property, the kinetic mass of a photon is m equals to E upon c square, because we know that very famous equation for particle nature, E equals to mc square. M equals to E upon c square. That means E equals to mc square. But again, E equals to h mu. E equals to h mu. E equals to h nu, E equals to mc square. Okay, so h nu equals to mc square, but nu equals to c upon lambda. Okay, that's why we are substituted here. Nu equals to c lambda. P equals to E by C equals to h upon lambda, because very famous equation that lambda equals to h upon P. Hmm? So P equals to h by lambda. Next, photon travels in a straight line. Next property, energy equal to. Okay, next one, energy of photon depends upon frequency of the photon. So energy of the photon does not change when photon travels from one medium to another medium. Now the question is, what is the frequency? When we are discussing about wave nature, this is a wave. Here, there are 3 points. The first one, the wave starts from time of 0 and it ends at t, right? So t is periodic time. T is what? Periodic time. How it can be defined? That is the time required to complete one oscillation. The time required to complete one oscillation, that is called periodic time t. And 1 upon t is called frequency. Okay. Here, this distance from starting point and end point is called lambda. What is lambda? Lambda is wavelength. Okay, wavelength of a wave, and it is to be defined as distance in between two successive crests, two successive trough, or two successive mean positions. Okay, so wave starts from this. What is wave? Wave is simply an oscillatory disturbance traveling through medium. What is wave? Wave is an oscillatory disturbance traveling through medium. Okay, so energy of a photon depends upon frequency of the photon. What is frequency? Frequency is simply 1 upon t. What is t? Periodic time of oscillation. So energy of the photon does not change when photon travels from one medium to another. Next property, wavelength. Next property, wavelength of photon changes in different media. So velocity of photon is different in different media. When photons are electrically neutral, photons may show diffraction under given conditions. Photons are not deviated by magnetic and electric fields. Okay, this is all about photons. In a summary, we can say a photon travels at a speed of light c. Then different equations. One more thing, that energy of a photon depends upon frequency of the photon. Next, what is photoelectric effect? Very simple concept, that when photons as a part of light photons is a part of light when these photons are interacting with certain metals. Then these photons, after interacting with metal surfaces, electrons are ejected or electrons are emitting out. Okay, so that some current is allowed to flow through the circuit, that is called photoelectric effect. What is written? The phenomena of emission of electrons from metal surfaces exposed to light energy. When light energy or X-rays, gamma rays, ultraviolet rays, visible light, and even infrared rays are interacting with metal surfaces, then electrons are ejected through that particular metal, so that current flows, and that current flow is called photoelectric current, and the effect is called photoelectric effect. The phenomena of emission of electrons from the metal surfaces exposed to light energy of suitable frequency is known as photoelectric effect. Photons interacting with metal surfaces causes to induce some current. Okay, and that effect is called photoelectric effect. Next, non-metals also show photoelectric effect. Liquids and gases also show this effect, but to limited extent. Okay, means different metals require different types of photons. Photons are varying in their frequency, in their periodic time, in their wavelength, and in their energy. Because we know that E equals to h mu. E equals to h mu. But what is mu? Mu is simply C upon lambda. And obviously, lambda is different for different types of waves. And so that energy of the photons is different for different, like X-rays, gamma rays, UV rays, visible light, and so on. Okay. So when photoelectrons such as ultraviolet rays are going to incident on metal surfaces, then photoelectrons are ejecting out visible light. When interacting with metals other than alkali metals, has no emission of photoelectrons. Visible light, when interacting with alkali metals such as cesium, then photoelectrons are ejected out. But what is the condition? मग photoelectric effects on it. तो कुठल्याही मेटल सर्फेससाठी लागू होत नाही किंवा कुठल्याही रेडिएशनसाठी लागू होतोच असं नाही. पण जेव्हा काही रेडिएशन्स हॅव्हिंग सर्टन फ्रिक्वेन्सी above threshold frequency are going to interact with alkali metals, then photoelectric effect is observed. Okay, so this is experimental setup to study photoelectric effect. Okay, what it consists of? It consists of a recharge tube across which some electronic accessories provided here, like here is power supply voltage. When ultraviolet light is going to interact in the form of photons with this cathode surface, then these photons are interacting with metal surfaces, and it can be utilized by two methods. That is, first one, the energy of these photons are to be utilized by the cathode surface to eject the electrons to produce photoelectric effect, and remaining amount of energy is to be used to provide the kinetic energy to the emitted photons. And here anode is having negative potential, this is supplied, negative potential is given, sorry, positive potential is given to anode, and cathode is having the particular element. So in the presence of photons, these photons are going to interact with cathode surface. Ejection of electrons takes place. They are going to accelerate towards anode, and the photoelectric current is produced. Here, C is metallic cathode, A is metallic anode, W quartz window, and photoelectrons are attracted towards anode. Next, glass transmits only visible and infrared lights, but not UV light. Quartz transmits ultraviolet light. Next, when light of suitable frequency falls on metallic cathode, photoelectrons are emitted. These photoelectrons are attracted towards the positive anode, and hence photoelectric current is constituted. Next, here, uh, if you are just remembering this photoelectric effect, then we must again, in a summary, photoelectric emission is the phenomena of emission of electrons from surface of metals when light of suitable frequency falls on it. Emitted electrons are called photoelectrons. The number of photoelectrons emitted depends on intensity of incident light. When you are discussing about photoelectric effect, you should first clear the 3 points. That is, first one, threshold frequency, work function, and stopping potential. What is threshold frequency? It is the minimum amount of frequency of the photons interacting with metal surfaces to produce photoelectric effect. ओके, म्हणजे कमीत कमी फ्रिक्वेन्सीचे फोटॉन्स जर आपण सप्लाय केले तर त्या ठिकाणी जर फोटो इलेक्ट्रिक इफेक्ट प्रोड्यूस होत असेल, ऑब्झर्व होत असेल, तर त्या फ्रिक्वेन्सीला आपण थ्रेशोल्ड फ्रिक्वेन्सी असं म्हणतो. सो थ्रेशोल्ड फ्रिक्वेन्सी इज सिम्पली फॉर अ गिव्हन मेटल टू ऑब्झर्व photoelectric effect. We are required to supply radiations of certain minimum frequency below which no photoelectric current is observed. Okay, this minimum frequency of radiation is known as threshold frequency. It is denoted by mu 0. That is first point. Work function. Second aspect, that is the minimum amount of energy required to be provided to an electron to pull it out of the metal from surface is called as work function of the metal and is denoted by phi 0. इथे लक्षात घ्या की जेव्हा काही फोटॉन्स हे मेटल सरफेसेस किंवा अल्कली मेटलशी इंटरॅक्ट होतात तेव्हा त्या फोटॉन्सची एनर्जी हे 2 वेजनी युटिलाइज केली जाते. फर्स्ट वे, that is, it is to be used to knock out the electron from that metal surface, and that function is called work function. Work has to be done. Work has to be done to eject the electrons from the surface or from the metal in the presence of photons of certain frequency above threshold frequency. Okay, so that is called work function. And third point, that is stopping potential. Okay, stopping potential म्हणजे काय तर ज्या नेगेटिव्ह पोटेन्शियलला फोटो इलेक्ट्रिक करंट हा 0 होतो. ओके, when negative potential is applied to the plate A with respect to C, photoelectric current becomes 0 at a particular value of negative potential, which is called stopping potential or cut-off potential. Okay, when Okay, what is stopping potential? Stopping potential is when negative potential is applied to the plate with respect to C, the photoelectric current becomes zero at a particular value of negative potential called as stopping potential or cutoff potential. Okay, so first definition we have said about threshold frequency, second one that is work function, and third one stopping potential. What is threshold frequency? It is the minimum frequency photons required to absorb photoelectric current. It is denoted by mu zero. Mu zero. Okay, that is called threshold frequency. Second point, work function. What is work function and how it is denoted? Work function is simply uh, work to be done against the rejection of the electrons in the presence of photons. म्हणजे जेव्हा photons एक metal surface शी interact होतात त्यावेळेला अं, त्या surface मधून electrons eject करण्यासाठी काही काम करावं लागतं आणि त्याला म्हणतात work function. It is denoted by phi zero. Then next one, stopping potential. What is stopping potential? It is the negative potential required to apply in order to absorb photoelectric current as zero. Okay. Now, on this photoelectric effect, there are three variables. First one, intensity of incident light, frequency of incident light. Next one, stopping potential. Next one, photoelectric current. Next one, threshold frequency. Okay, let us see the effects of all these three parameters one by one. The first one, effect of intensity of incident light on photoelectric current. Next effect, effect of potential on photoelectric current. Which potential? That potential we are supplying in between cathode and anode. Okay. Next one, next point, that is effect of frequency of incident light on photoelectric current. And fourth point, effect of frequency of incident light on stopping potential. These are certain graphical representation of all these effects. So let us see first one, effect of intensity of incident light on photoelectric current. What is photoelectric current? Photons interacting with metal surfaces causes to induce certain current, and that current produced is called photoelectric current. What is intensity of incident light? Here, intensity is to be defined as I equals to P upon A. P upon A. But what is P? P is power. Power of incident light. And it is to be defined as rate of change of energy. E upon T, rate of change of energy per unit area of cross section. Per unit area of cross section. That is called intensity of incident light. I equals to P upon A. What is P? Power of the incident light, rate of change of energy, that is E of E upon T upon area of cross section. That is called intensity of incident light. Okay. So what is frequency? Frequency is simply 1 upon T. Frequency is 1 upon T. What is T? Periodic time of a wave. What is periodic time of a wave? That is simply time required to complete one oscillation. All these parameters you have studied in 11th standard. Okay, so for a fixed frequency, the photoelectric current increases linearly with increase in intensity of incident light. एका ठराविक फ्रिक्वेन्सीला जर फोटो इलेक्ट्रिक इफेक्ट हा ऑब्झर्व होतोय आणि ती फ्रिक्वेन्सी त्या फोटॉन्सची फ्रिक्वेन्सी जर फिक्स असेल तर फोटो इलेक्ट्रिक करंटवरती त्याचा परिणाम कसा होतो तर तो ग्राफिकल नेचरनी आपण दाखवलाय. So from the graph, it is very clear that as you go on changing the intensity of the photons, then the current, which current? Photoelectric current linearly increases. Linearly increases. Okay. The next point, effect of potential on photoelectric current means the potential we are applying in between cathode and anode. If you go on increasing that potential, then photoelectric current up to certain value of potential, it linearly increases, and beyond that particular value of this, this particular value of the potential applied from this point onward, from this potential onward, no rise in current is observed. Okay, so this part is coming under saturation current. म्हणजे एका ठराविक पोटेन्शियल पर्यंत आपण जेव्हा पोटेन्शियल वाढवत जातो त्यावेळेला आपल्याला फोटो इलेक्ट्रिक करंटमध्ये लिनियर इन्क्रीज दिसते, पण त्या पोटेन्शियलच्या पुढे जर आपण आणखीन पोटेन्शियल वाढवत गेलं तरी सुद्धा आपल्याला शार्प रायझिंग करंट व्हॅल्यू मिळत नाही. Okay, so that is potential of A. Then it is very clear that though our potential applied is zero, then also some current is observed. Some current is observed. Okay, so L2 is greater than L1. There are two cases, right? So L2 is greater than L1, and for uh, application of zero potential difference also some current is observed, which is that current, that is photoelectric current. For a fixed frequency and intensity of incident light, fixed frequency and intensity of incident light, the photoelectric current increases with increase in positive potential applied to the anode. When all the photoelectrons reach the plate A, current becomes maximum and is known as saturation current. This part is called saturation current. When all the photoelectrons reach the plate A, current becomes maximum. Okay. मग ह्या फोटो इलेक्ट्रिक करंटला आपल्याला झिरो करायचं असेल तर आपल्याला निगेटिव्ह पोटेन्शियल अप्लाय करावं लागतं, आणि निगेटिव्ह पोटेन्शियल ज्या ठिकाणी फोटो इलेक्ट्रिक करंट हा झिरो ऑब्झर्व होतो त्या पोटेन्शियलला आपण काय म्हटलं तर stopping potential. Okay, when the potential is decreased, the current decreases but does not become zero at zero potential. This shows that even in the absence of accelerating potential, म्हणजे आपण जे पोटेन्शियल कॅथोड आणि ॲनोडच्या अक्रॉस अप्लाय केलेलं होतं ते आपण झिरो केलं तरी सुद्धा काही फोटो इलेक्ट्रिक करंट हा ऑब्झर्व होतो. When the potential is decreased, the current decreases but does not become zero at zero potential. This shows that even in the absence of accelerating potential, a few photoelectrons manage to reach plate on their own due to their kinetic energy. When negative potential is applied to plate A, with respect to C, C is the cathode, or you can call the target material from which you are getting photoelectric current, and A is anode, which is having the positive supply. Photoelectric current becomes zero at a particular value of negative potential called as stopping potential or cutoff potential. Intensity of incident light does not affect the stopping potential. Okay. Next, the third point, effect of frequency of incident light on photoelectric current. Effect of frequency of incident light, frequency change झाली की त्याची एनर्जी चेंज होणार. फोटॉन्सची फ्रिक्वेन्सी जर चेंज झाली तर त्याची फ्रिक्वेन्सी चेंज झाली त्याची एनर्जी चेंज होणार. मग त्याचा फोटो इलेक्ट्रिक करंट जो काही आपण ऑब्झर्व करतोय त्याच्यावरती इफेक्ट कसा होणार. For a fixed intensity of incident light, the photoelectric current does not depends on frequency of the incident light because the photoelectric current simply depends on the number of photoelectrons emitted and in turn on the number of photons incident and not on energy of photons. Because for a single photon, we have the equation E equals to h nu. And if n number of photons are available, then E equals to n, sorry, I'm sorry. Okay, just now we said that. Okay, for a single photon, E equals to h nu. But for n number of photons, because we are saying that a stream of photon is nothing but radiation. A stream of photons is nothing but radiations. Okay, for a single photon, we have the equation E equals to h nu. What is h? H is Planck's constant. What is nu? Nu is the frequency of a photon, frequency of a wave. Okay, and what is E? That is energy. So for a single photon, E equals to h nu. For n number of photons, the equation would be E equals to nh nu. E equals to nh nu, right? So what we are calling, जर हे number of photons increase झाले तर ज्या मेटल सरफेस पासून इलेक्ट्रॉन्स इजेक्ट होतात त्यांची संख्या पण वाढते. ओके, बघा मग एक सिंगल फोटॉन हा एक इलेक्ट्रॉनला इजेक्ट करतो. असे एन नंबर ऑफ फोटॉन्स जर कॅथोड सरफेस वरती इन्सिडेंट झाले तर एन नंबर ऑफ इलेक्ट्रॉन्स एमिट होणार. आणि एन नंबर ऑफ इलेक्ट्रॉन्स एमिट झाले ह्याचाच अर्थ काय तर फोटो इलेक्ट्रॉन इफेक्ट हा फोटो इलेक्ट्रिक करंट हा इन्क्रीज झाला. ओके, so for a fixed intensity of incident light, the photoelectric current does not depend on frequency of incident light because photoelectric current simply depends on number of photoelectrons emitted and in turn on number of photons incident and not on energy of photons. Then, what is the effect of frequency of incident light on stopping potential? For a fixed intensity of incident light, photoelectric current increases and is saturated with increase in positive potential applied to the anode. However, the saturation current is same for different frequency. म्हणजेच different frequency चे photon हे जर आपण सरफेसवरती म्हणजे मेटल सरफेस और अल्कली मेटल्सवरती इन्सिडेंट केले तर सॅच्युरेशन करंट हा सेम पोटेन्शियलनं ऑब्झर्व होतो. दो V2 is greater than V1. What is observed? Stopping potential is at different location. Stopping potential is at different location, but saturation current is observed at the same potential. Effect of frequency of incident light on stopping potential. For a fixed intensity of incident light, photoelectric current increases and is saturated with increase in positive potential applied in between cathode and anode. However, saturation current is same uh, for different frequencies of the incident light. When potential is decreased and taken below zero, then photoelectric current decreases to zero, but at different potential. Stopping potentials is different आहे. Saturation current हा at the same potential. जरी आपण दोन वेगवेगळ्या फ्रिक्वेन्सीचे फोटॉन्स हे टार्गेट मटेरियलवरती इन्सिडेंट केले तरी सुद्धा सॅच्युरेशन करंट हा सेम पोटेन्शियल दिसतो, पण त्याचे स्टॉपिंग पोटेन्शियल्स हे मात्र काय असतात, डिफरंट असतात. ठीक आहे. हायर द फ्रिक्वेन्सी, हायर द स्टॉपिंग पोटेन्शियल. That is, stopping potential is directly proportional to frequency of the photons. Stopping potential is directly proportional to the frequency of the photons. That is the effect of frequency of incident light on stopping potential. Next, what is threshold frequency? Just now we defined threshold frequency is the minimum frequency of the photons required to eject the electrons to produce photoelectric effect. That we have said, right? So threshold frequency, if you are plotting the graph in between this, if you are plotting the graph in between different frequencies versus the stopping potential, then what you are observing here, that is, graph between stopping potential and frequency does not pass through the origin. This is the property. It shows that there is a minimum value of frequency called as threshold frequency, and it is different for different elements. It is different for different elements. What is this frequency? This frequency is called threshold frequency. Okay. So below which it is not possible to observe photoelectric effect, and this threshold frequency is different for different elements. You have to remember this. So below which photoelectric emission is not possible. However, higher is the intensity of incident light. So it depends on nature of the metal. Just now we said. Then in summary, we can say lots of photoelectron emission. That is first point. It requires threshold frequency. It has some work function. It is having some stopping potential. Okay. So for a given substance, there is a minimum value of frequency of incident light called as threshold frequency, below which no photoelectric emission is possible. However, the intensity of incident light may be. म्हणजे इंटेन्सिटी कितीही काही चेंज हो, पण फ्रिक्वेन्सी ठराविक इतकी फ्रिक्वेन्सी जर तुम्ही अप्लाय केली नाही तर आपल्याला फोटो इलेक्ट्रिक इफेक्ट ऑब्झर्व होत नाही. द नंबर ऑफ फोटो इलेक्ट्रॉन्स emitted per second, that is photoelectric current, is directly proportional to intensity of incident light, provided the frequency is above the threshold frequency. The next one, the maximum kinetic energy of the photoelectrons is directly proportional to frequency, provided the frequency is above the threshold frequency. Okay, the maximum kinetic energy of the photoelectrons is independent. The maximum kinetic energy of the photoelectrons is independent of the intensity of the incident light. Next one, the process of photoelectric emission is instantaneous. Hello. कोण? Sorry. Okay. The process of photoelectric emission is instantaneous. There is no time delay. Okay. The process of photoelectric emission is instantaneous. म्हणजे असा फोटॉन इन्सिडेंट झाला की पटकन फोटोइलेक्ट्रिक इफेक्ट ऑब्झर्व होतो, प्रोव्हाइडेड the threshold frequency is required. Okay, the process of photoelectric emission is instantaneous. That is, as soon as the photons of suitable frequency falls on the substance, it emits photoelectrons. The photoelectric emission is one-to-one. That is, for every photon of suitable frequency, one electron is emitted. That we have described. The next one, Einstein's photoelectric equation. Just now we have said that whatever the energy of the photons going to interact with the metal surfaces or going to interact with the target material has to be utilized for two purposes. The first one, that is part of the energy, is used to overcome the surface barrier and come out of the metal surface. This part of the energy is called work function. Okay, work function साठी काही amount of energy utilize केली जाते आणि remaining amount of energy is to be used in giving a velocity v to the emitted photoelectron. Okay, this is equal to the maximum kinetic energy of the photoelectrons, where m is mass of the photoelectron. So, in summary, we can say that if h nu is the energy of incident photon, then part of it is to be used for work function and remaining amount of energy is to be used to have the motion of the electrons ejected due to the phenomena of photoelectric effect. म्हणजे जे काही फोटो इलेक्ट्रॉन्स एमिट झालेले असतात त्यांना मोशनमध्ये आणण्याचं काम हे तिथे केलं जातं. आणि आपल्याला माहिती आहे कुठल्याही पार्टिकल्सना इलेक्ट्रॉन्सना जर आपण मोशनमध्ये आणायचं असेल तर त्याला एनर्जी असोसिएट असते आणि त्या एनर्जीला म्हणतात कायनेटिक एनर्जी. ओके, सो kinetic energy plus work function. And what is this work function? Work function is simply denoted by h into mu zero. What is mu zero? That is threshold frequency, mu zero, plus half mv square maximum. Okay? So incident photon eject the electron by overcoming work function. Work function, because we know that solid or matter consists, if the matter is existing in the form of solid, solid consists of large number of atoms, atoms consist of electrons. There is a concept of ionization potential. In order to overcome this ionization potential, we need to apply the external energy to get free the electrons from that target material. Okay, so that concept is associated with work function, and work function equals to h into mu zero. Do not have the confusion in between this v is this velocity, small v, that is velocity, then v0, that is voltage applied in between cathode and anode surface, and there is a third parameter, that is mu zero. Mu, have the notations, have the differences. Mu is velocity, v0 is applied voltage, and mu zero, that is threshold frequency. Okay, so that is shown here. E equals to h nu plus work function plus remaining amount of energy to accelerate the ejected electrons, so that photoelectric current is produced, right? Okay, now by rearranging these terms, h nu minus h nu zero equals to half mv square maximum. H is to be taken common, so this is not v, this is simply mu. Mu means frequency of the photons, mu zero threshold frequency. So what is the formula? When half mv square, you have to remember this formula to solve the number of problems, remember. Okay, so that is first aspect. Then one more equation you have to remember, that 1/2 mv square equals to E into V0. Okay, into V0, half mv square. Change in kinetic energy equals to work done. Change in kinetic energy equals to work done, and that work done, that is E into V0. V is the applied potential. Okay, this formula also you have to remember to solve the number of problems. The next one, verification of laws of photoelectric emission based on Einstein's photoelectric equation. Just now we have said half n is equals to h into nu minus mu 0. If nu is less than mu 0, if the frequency of the photons incident is less than threshold frequency, then half mv square maximum is negative, so that no photoelectric current is observed. Okay. Therefore, for photoelectron emission to take place, mu should be greater than mu 0. That is first aspect we can obtain from this equation, right? If mu is less than mu 0, means this term will become negative. No? And for negative value, we can't observe the photoelectric effect. Since one photon emits one electron, so the number of photoelectrons emitted per second is directly proportional to intensity of incident light. For single photon, we are getting ejection of single electron. For n number of photons, we are getting large number of photoelectrons. It is clear that half mv square maximum is directly proportional to mu. Huh? It's a mu, not v. Half mv square. This v is velocity of the electrons. Okay, and this is mu. Mu is the frequency. It is clear that half mv square maximum is directly proportional to mu, as h and mu 0 are constant. This shows that kinetic energy of the photoelectrons is directly proportional to frequency of the incident light. Right? Then photoelectric emission is due to collision between a photon and an electron. As such, there cannot be any significant time between means the process is instantaneous. It is found that delay is below 10 raised to minus 8 seconds. Next one, applications of photoelectric effect. First one, automatic fire alarm, automatic burglar alarm, scanners in television transmission, reproduction of sound in cinema film, in paper industry to measure the thickness of paper, to locate flaws or holes in the finished goods, in astronomy to determine opacity of solids and liquids, automatic switching of streetlights to control temperature of furnace, photometry, beautymeter to measure the fair complexion of skin, light meters used in cinema industry, photoelectric sorting, photo counting, and metrology department. Okay, there are three aspects, that is photoconductive cells, then photovoltaic cells, right? And this is the next, that is photoelectric effect. म्हणजे फोटॉन्स जेव्हा इंटरॅक्ट होतात तिथे कंडक्टिव्हिटी वाढते, ते व्होल्टेज इन्क्रीज होतं आणि इथे करंट इन्क्रीज होतो आणि त्याच्यानुसार त्याचे डिफरंट ॲप्लिकेशन्स आहेत. नाउ द नेक्स्ट पार्ट, ड्युअल नेचर ऑफ रेडिएशन्स अँड मॅटर. आता हा कन्सेप्ट आलाच कसा, हा मेन प्रश्न आहे. ओके, ड्युअल नेचर ऑफ रेडिएशन अँड मॅटर. आपण असं म्हणतो की युनिव्हर्समध्ये फक्त दोनच एंटिटीज अस्तित्वात आहेत, की फर्स्ट म्हणजे मॅटर आहे आणि सेकंड म्हणजे फॉर्म ऑफ एनर्जी. एनर्जी आणि मॅटर हे दोनच आस्पेक्ट युनिव्हर्समध्ये आहेत. मग काही फिजिक्स एक्सपेरिमेंट जर आपल्याला एक्सप्लेन करायचे असतील, लाईक reflection, diffraction, interference, diffraction. In order to explain all these phenomena, we should have to take the support of wave nature associated with light or associated with radiations. Okay, but in certain experiment, that is in order to explain this photoelectric effect or quantum effect, we need to take the support of the particle nature associated with light or with the radiations. Okay, radiation is simply a form of energy which are varying in their frequencies and in their energies. ठीक आहे. मग मग जर radiations हे दोन्ही नेचर दाखवत असतील, की पार्टिकल नेचर पण दाखवतोय आणि वेव्ह नेचर पण दाखवतोय, तर उलट का नाही होऊ शकत? तर मॅटर इज हॅव्हिंग पार्टिकल नेचर. Okay, matter is having particle nature. This matter also should have to exhibit wave nature. That is the concept put forwarded by Louis D. Broglie in the year 1924. What he has suggested, he suggested that any moving particle is associated with a wave, and that wave is called a matter wave. Okay, matter, particle. Okay, when a particle is in motion, it is associated with a wave, and that wave is called de Broglie wave, and that wave is called matter wave. The concept is here that radiations, this here, radiation, if it is, we are considering as wave nature, and matter is having particle nature. Then we know that wave nature is associated with wave nature is characterized by amplitude, frequency, periodic time, phase difference. All these are characteristics of wave nature. Okay, and what is about particle nature? If it is having particle nature, then it should have some specific mass, some specific momentum, etc. Okay, so these are the characteristic properties of the wave nature and particle nature. म्हणजे पार्टिकल आपण कन्सिडर केलं तर त्याला मास असेल, मोमेंटम असेल. ओके, पण जर वेव्ह असेल तर त्याला आपण असं म्हणत नाही की त्याला मास आहे, त्याला मोमेंटम आहे. तर आपण ते फीचर्स तशा पद्धतीने एक्सप्लेन करतो. तर त्याला अँप्लिट्यूड आहे, त्याला फ्रिक्वेन्सी आहे, त्याला वेव्हलेंथ आहे, त्याला पिरियोडिक टाइम आहे, एटसेट्रा. ओके, सो देर आर टू डिफरंट आस्पेक्ट्स. नाउ ऑन द अदर हँड, तर आपण असं होतं की रेडिएशन जर ड्युअल नेचर दाखवत असतील, काही एक्सपेरिमेंट एक्सप्लेन करण्यासाठी वेव्ह नेचर, काही रिमेनिंग एक्सपेरिमेंट म्हणजे काही एक्सपेरिमेंट्स एक्सप्लेन करण्यासाठी पार्टिकल नेचरचं जर आपण सपोर्ट घेत असू, तर मॅटरच्या बाबतीत सुद्धा ड्युअल नेचर दिसलं पाहिजे. हा कन्सेप्ट पुढे आला आणि त्यालाच म्हणतात ड्युअल नेचर ऑफ radiation and dual nature of matter. And this concept was put forwarded in the year 1924 by scientist Louis D. Broglie. He suggested that any moving particle is associated with a wave, and that wave is matter wave, and the wavelength of that wave is expressed in terms of de Broglie wavelength, and the de Broglie wavelength is to be expressed in terms of lambda equals to h upon mv. Okay, lambda equals to h by mv. Okay, lambda is the characteristic of wave nature, m is the characteristic of wave nature, mv is the m is the characteristic of particle nature, mv is the characteristic of that is called as momentum, that is particle nature. Then how this equation arises, किंवा हे इक्वेशन त्याला आपण de Broglie इक्वेशन म्हणतो, ते पण आपण इथे सांगतोय. ठीक आहे. ऑन द अदर हँड, क्वांटम थिअरी ऑफ इलेक्ट्रोमॅग्नेटिक रेडिएशन सक्सेसफुली एक्सप्लेन द फोटो इलेक्ट्रिक इफेक्ट, क्वांटम इफेक्ट, black body radiations, X-ray spectra, etc. Thus, radiations have dual nature, that is wave nature and particle nature. ठीक आहे, आता आपण बघितलं. Louis D. Broglie suggested that particles like electrons, protons, neutrons, etc. have also dual nature. Must, that is, they also can have, should have particle as well as wave nature. In no experiment matter exists both as particle and as a wave. म्हणजे काही एक्सपेरिमेंट एक्सप्लेन करण्यासाठी वेव्ह नेचर, काही एक्सपेरिमेंट एक्सप्लेन करण्यासाठी पार्टिकल नेचर. पण असं कुठेही दिसलं नाही की एकच एक्सपेरिमेंट आपण दोन्ही पद्धतीने एक्सप्लेन करू शकतो. ठीक आहे. इन नो एक्सपेरिमेंट मॅटर एक्झिस्ट both as a particle and as a wave simultaneously. It is either the one or the other aspect. That is, two aspects are complementary to each other. His suggestion was based on the nature loves symmetry and the universe. This is very important. Nature loves symmetry. Why? If we are saying the universe is made up of particles and radiations, and both entities must be symmetrical, then if radiations are exhibiting dual nature, particles should have. Okay, that is the concept. Next one. De Broglie. Listen. According to T. Broglie, a moving material particle can be associated with a wave. That is, a wave can guide the motion of the particle. The wave associated with the moving material particles are known as de Broglie waves or matter waves. Expression for de Broglie wave: according to quantum theory, energy of the photon is E equals to h nu equals to hc upon lambda. Nu is what? Nu is the frequency. And how it can be expressed? Nu equals to c upon lambda. What is c? C is the velocity of light. What is lambda? Wavelength of the light. Wavelength of a wave. According to Einstein's theory, we have the energy of the photon is mc square. According to quantum theory, we are having this is first equation, and according to Einstein's theory, we have second equation. This both are the values of energy, so we can equate them. And after equating, we found h nu equals to mc square, nu equals to c by lambda, hc upon lambda, hc upon lambda. If you are comparing here, then it will be hc upon lambda equals to mc square. Okay, so cc will get cancelled. So what is left here? That is simply h by c. H by c, m is also coming here. H by mc equals to lambda. Okay, this is observed for light wave because this is the velocity of light. And if we are saying that V is the particle velocity, इथे c ची व्हॅल्यू काय आहे तर 3 to 10 raised to 8 मीटर पर सेकंड ही त्याची व्हेलॉसिटी ऑफ लाईट आहे. दॅट्स द स्पीड ऑफ लाईट. ठीक आहे. मग आपण असं म्हणतो की जर मॅटर ॲज अ पार्टिकल इज इन मोशन, then it is associated with a v. V is the velocity of a particle. V is velocity of a particle. Then c must be replaced by v. C must be replaced by v. So this expression is coming here as lambda equals to, though it is h by mc, we are replacing this c by v. Okay, so it is observed here. This h by mv. What is v? V is the particle velocity. What is p? Momentum of a particle. How it is defined? P equals to mc. That is for photon as a part of light. Okay. But if a matter having mass m and velocity v, then momentum is m into v. So it is the expression for de Broglie wavelength. Now there are different forms of this wavelength lambda. The very fundamental first one, lambda equals to h by mv. Okay, h by p. Second equation, lambda equals to h by p. Third equation, lambda equals to h upon square root of 2 mev. Third form, fourth form, lambda equals to h by square root of 2 me. What is E? E is the energy of a matter or energy of a particle which is moving with certain velocity v. Okay, so lambda equals to h upon square root of 2 me. There are different forms associated with de Broglie wavelength. What is de Broglie wavelength? De Broglie wavelength says that matter wave or the particle such as electron is in motion with certain velocity v, then wavelength of that wave is expressed in terms of these fundamental equations. Lambda equals to h by m v, lambda equals to h by p, lambda equals to h upon square root of 2 m e v. This v is not velocity. This v is the accelerating potential difference. This v is accelerating potential difference. Okay, lambda equals to h upon square root of 2 m e. What is e? Energy of the photon. Okay, sorry, energy of the particle which is in motion with certain velocity v. Next, if the particle is at rest, then de Broglie wavelength is infinite. Such a wave cannot be visualized. De Broglie wavelength is inversely proportional to mass of the particle. आता इथेच आपण ह्याच्या कॅरेक्टरिस्टिक फीचर्स सुद्धा डिफाईन करू शकतो. आपण असं म्हटलं की एखाद्या पार्टिकलचं मास हे जास्ती असेल तर त्याची वेव्हलेंथ काय असणार तर कमी असणार. एखादा पार्टिकल लोअर व्हेलॉसिटी मोशन मध्ये असेल तर त्याची वेव्हलेंथ काय असणार त्याची सॉरी lower the velocity, higher will be the wavelength. Lighter is the particle, higher will be the wavelength. Heavier is the particle in terms of mass, then shorter will be the wavelength. Higher is the velocity of the particle, then again shorter will be the wavelength of matter wave. चार कॅरेक्टरिस्टिक आपण इथे डिफाईन केले. ठीक आहे. नेक्स्ट, de Broglie wavelength is inversely proportional to mass of the particle. Just now we have said that the wavelength associated with a heavier particle is smaller than that with a lighter particle. And opposite is the case. Vice versa. De Broglie wavelength is independent of the charge of the particle. De Broglie wavelength is independent of the charge of the particle. Okay. Matter waves like electromagnetic waves can travel in vacuum and hence they are not mechanical waves. Matter waves are not electromagnetic waves because they are not produced by accelerated charges. Matter waves are probability waves, amplitude of which gives the probability of existence of the particles at that point. Next, in order, if we are defining certain properties associated with the matter waves, then one of the contradiction is arising that the phase velocity we are getting as c square upon v. What is v? V is the particle velocity and u is the phase velocity. Okay, the phase velocity of a matter wave is exceeding to the velocity of a light, because we know that velocity of a light is the maximum speed, that is 3 into 10 raised to 8 meter per second, and velocity of a particle, though it is larger as compared to the velocity of light, that particle cannot attain the velocity of light. Okay, and here is the contradiction, that phase velocity of the matter wave is increasing and to the assumption that the velocity of light is the last limit of speed. Okay, so there is a contradiction in whatever the expressions we are getting. Okay, so scientists are just in confusion that what to believe and whether to say that matter waves are present or not. And for that purpose, Defijan and Germer have done this particular experiment, which is the supportive evidence to say that matter waves are present. Okay, so that experiment is as shown in diagram. What is observed here? A beam of electrons emitted by electron gun is made to fall on nickel crystal cut along cubical axis at a particular angle. Okay, this is the nickel crystal. Here is a filament. Filament is attached with this low power supply, so that in the presence of low power supply, this filament is able to emit the electrons, and those electrons are going to incident on this particular nickel crystal. Okay. So this crystal is consisting of large number of set of planes, and here is the detector. Means what happens in the presence of these electrons when they are interacting with such crystal, then crystal can act as a three-dimensional diffraction grating. So that diffraction effect is observed. म्हणजे इलेक्ट्रॉन्स हे एखाद्या क्रिस्टलवरती जाऊन इन्सिडेंट होतात तेव्हा तो क्रिस्टल हा डिफ्रॅक्शन ग्रेटिंग म्हणून ऍक्ट करतो आणि आपल्याला डिफ्रॅक्शन इफेक्ट ऑब्झर्व करतो. ठीक आहे, आपल्याला डिफ्रॅक्शन इफेक्ट हा तिथे दिसतो. मग इथे आपण डिटेक्टर प्लेस केला आणि फक्त हा अँगल आपण चेंज करत गेलो. अँगल ऑफ इन्सिडन्स दिस थीटा. थीटा इज कॉल्ड glancing angle. What is glancing angle? Glancing angle is the incident angle made by the beam of electron or the incident electrons with the set of parallel planes. With the set of parallel planes. That is called glancing angle. Glancing angle is itself the angle of incidence. Then you will find here that when this theta is likely to change, when you are changing this angle theta, then at a particular position of this detector and at the particular value of the potential difference applied in between cathode and anode, certain conditions are observed. Those are explained here. When the what is the first sentence? A beam of electrons emitted by the electron gun is made to fall on nickel crystal cut along cubical axis at a particular angle. The scattered beam of electrons is received by the detector, which can be rotated at any angle. The energy of the incident beam of electrons can be varied by changing the applied voltage in between this cathode and anode. Then intensity of scattered beam of electrons is found to be maximum when angle of scattering is 50 degree and the accelerating potential is 54 volts. Okay, this is the condition at which maximum diffraction, maximum scattering is observed. Okay, so if you're just taking all the values and applying the condition of 2d sin theta equals to n lambda, which is the famous equation, which is called Bragg's equation. So you'll observe here this total angle is 180 degree. This is the lattice plane. This is the lattice plane, and this is the incident angle. Okay. So this complete is 180 degree. So here is theta glancing angle. Here is also theta glancing angle, and this is the angle of diffraction. Angle of diffraction phi. Theta plus theta, 2 theta, 2 theta plus phi. Phi, if you are seeing that phi equals to 50 degree, then theta plus 50 degree equals to 180 degree. It should occur. That is 2 theta plus 50 equals to 180. That is theta equals to 65 degree. For nickel crystal, lattice spacing D equals to 0.91 Armstrong unit. And for first order spectra, for n equals to 1, electron diffraction condition is to be followed, which is given by Bragg's equation. Bragg's equation says that 2d sin theta equals to n lambda, and that gives you lambda equals to 1.65 Armstrong unit. That is as per the Bragg's condition. Okay, the similar value we can obtain by using de Broglie equation, which is the de Broglie equation. Lambda equals to h upon square root of 2m Okay, now let's see. म्हणजे एका मेथडनी आपण काय केलं तर de Broglie equivalent 1.65 Armstrong unit येते हे आपण इथे प्रूव्ह करतो. At the same time, if you are plotting the graph in between intensity of scattered beam versus incident beam, then you will get different conditions. But here you can get the prominent situation where intensity of scattered beam is maximum. At which condition? At 54 volt as the applied potential, and at what angle? Angle of diffraction, that is phi equals to 50 degree. Okay. So intensity of scattered beam at 54 volt will provide you the maximum intensity of the scattered beam. Now, according to the Broglie equation, lambda equals to h upon square root of 2m EV. 2m EV, right? So lambda equals to, what is m? M is the mass of an electron, because the beam of electron we have utilized. Mass of electron. What is the value of mass of electron? M equals to 9.1 into 10 raised to minus 31. It's good. Spread out. It's spread out by the financial agents that's happening. मग अशी तसंच झालं. हा आता ते प्रेस होत I'm sorry. So the value of mass of electron, you note with that, 9.1 into 10 raised to minus 31 kg. If the particle is changed, obviously this mass is going to change, right? So what is E? E is charged on an electron. Its value is 1.6 into 10 raised to minus 19 coulomb. Minus 19 coulomb. Charge is to be expressed in terms of coulomb. So it's a 1.6 into 10 raised to minus 19. And what is the value of H? H is Planck's constant, 625 into 10 raised to minus 34 joule seconds. Okay. So H equals to 6.625 into 10 raised to minus 35 joule per second. And if you're substituting all the values here in addition to the voltage applied, that is 54 volts. Okay. So if you're substituting, lambda equals to 6.625 into 10 raised to minus 34 upon square root of 2 into 9.1 into 10 raised to minus 31 into 1.6 into 10 raised to minus 19 into V. How much is that V? V is the 54 volts. Okay. And if you are calculating all this, then lambda is coming to be 12375 Armstrong unit upon square root of V. What is this V? V is not the velocity. V is called potential applied, accelerating potential difference. Accelerating potential difference. ठीक आहे. सो एखाद्या पार्टिकलला जर मोशन मध्ये आणायचं असेल तर आपल्याला काहीतरी एक्सटर्नल पोटेन्शियल अप्लाय करावं लागतं आणि त्या पोटेन्शियलला आपण म्हणतो ऍक्सिलरेटिंग पोटेन्शियल डिफरन्स. Okay, so that value is coming like this. And now if you are substituting, I'm sorry, 12.375. Yeah, the answer is given here. There is a correction. हे सगळं सबस्टिट्यूट करा आणि चेक करा की हे जर इतकं येतं 1 2 3 7 5 into 10 raised to something -7 करेक्ट असं येतं -7 and that -7 if you are converting in terms of -10 then the decimal point we need to shift from 1 to 3 and it coming as 12.27 Armstrong unit. What is the value of Armstrong unit? What is Armstrong unit? Okay, let me explain. One Armstrong unit, all this information you should know while solving problems on the wave nature. Okay, one Armstrong unit equals to 1 into 10 raised to -10 meter, or one Armstrong unit equals to 1 into 10 raised to -8 centimeter. Okay, one Armstrong unit, that means 1 into 10 raised to -10, -10 meter. So 12.27 into 10 raised to -10 upon square root of V. And if you are substituting this V as this 54-fold, then it is also that the probability length is also approaching to 1.67 Armstrong unit. By the first method, that is using the probability equation, we have reached as lambda equals to 1.65 Armstrong unit by using the probability condition. And if we are assuming matter as a wave nature, then the value is coming lambda equals to 1.67 Armstrong unit. Okay, which is in close agreement with each other. There are two different methods by which we have calculated this value, but both are matching with each other. So we have to believe on the presence of matter waves. Understood? So this is all about photoelectric effect, dual nature of radiation, dual nature of matter, and so on. So ultimately, what you should remember, okay, what you should remember, okay, the first one, in a summary, you should remember, the following points. The first one, that E equals to H nu, E equals to H into C upon lambda, E equals to H nu for single photon, E equals to N H nu for large number of photons, then E equals to mc square. Then next one, in order to have the equation for photoelectric effect, you should know total energy of the photon interacting with the target material to observe the photoelectric effect. That E is to be utilized for two purposes. That is, first one, to achieve certain kinetic energy plus work function. Work function is to be given or denoted by phi. One more method, 1/2 mv square maximum. The velocity attended by ejected photoelectrons will be maximum by just following this equation, that if is zero, potential difference applied. Right? The same equation we could write as h nu, E equals to h nu equals to 1/2 mv square plus plus phi. Phi means work function, that is h nu 0. Therefore, 1/2 mv square equals to h nu minus h nu 0 equals to h into mu minus mu 0. Okay, so this is first part. these expressions you have to remember while solving the problems. Remaining part is very clear. And for de Broglie equation, we should have the fundamental equations like okay, lambda equals to h upon mp equals to h upon p. Then lambda equals to h upon square root of 2 MEP. Be clear for the notations. This small v velocity of a particle, large V, that is potential, which potential, applied potential V, and nu, nu is frequency of a photon. If this is clear, there is no any problem solved based on this particular topic. In the next lecture, we will consider the large number of problems. Just take one of the equation. Just wait for 5 minutes. Wait for 5 minutes. Here. Yeah. Such type of problems we need to solve. There are large number of problems here to make a practice to solve all these problems. Okay. So we'll discuss few of them. We'll continue for the next lecture. Just randomly we are discussing whatever we have learned up till now on a photosensitive material. Photosensitive in the sense जी मटेरियल्स आपण आपल्याला फोटो इलेक्ट्रिक इफेक्ट देतात अशी फोटोसेन्सिटिव्ह मटेरियल when frequency of incident radiation is increased by 30%, kinetic energy of the emitted photoelectron increases from 0.4 electron volt to 0.9 electron volt. The work function of the surface is ओके. तर इथे 1 इलेक्ट्रॉन हे ऑप्शन्स दिलेत त्यांनी. मग आपल्याला इक्वेशन हे माहिती आहे कुठलं एच न्यू इक्वल्स टू कायनेटिक एनर्जी प्लस वर्क फंक्शन. एच न्यू इक्वल्स टू द फर्स्ट इक्वेशन फॉर फर्स्ट वन दॅट इज 0.4 प्लस 5. म्हणजे दोन केसेस आहेत. एका केसमध्ये कायनेटिक एनर्जी ही 0.4 इलेक्ट्रॉन व्होल्ट आहे आणि जेव्हा आपण फ्रिक्वेन्सी 30% इन्क्रीज करतोय तेव्हा तीच कायनेटिक एनर्जी 0.9 इलेक्ट्रॉन व्होल्ट इतकी येते. तर वर्क फंक्शन काय असेल असा प्रश्न आहे. सो वी हॅव टू इक्वेशन्स. बेसिक फंडामेंटल इक्वेशन इज दिस थिंग. एच न्यू इक्वल्स टू कायनेटिक एनर्जी प्लस वर्क फंक्शन. जस्ट नाउ वी हॅव सेड दॅट एच न्यू इक्वल्स टू 0.4 प्लस 5 फॉर फर्स्ट सेट. सेकंड सेट काय केलं 30% आपण त्याची फ्रिक्वेन्सी वाढवली तर एच न्यू ओरिजिनल प्लस 0.3 एच न्यू. ओके. 30% that is 0.3 h nu equals to what is the kinetic energy increase 0.9 plus 5. So comparing these two equations, what we can write h nu plus 0.3 h nu, that is 1 h nu plus 0.3 h nu, 1.3 h nu equals to 0.9 plus 5. Okay. So 1.3 and the fundamental equation first, h nu equals to 0.4 plus 5. 0.4 plus 5, 1.3 is taken common. For h nu, we have substituted 0.4 plus 5 equals to 0.9 plus 5. Okay. And if you are solving this, then 13 fours are 52, means 0.52 plus 1.35 equals to 0.9 plus 5. Okay. So solving this, 1.35 minus 5. This 5 we have to come to this side. and 0.9 minus 0.52. So it's coming as 0.39 equals to 0.38. Sorry, 0.35, 1.35 minus 5, that is 0.35 equals to, this one is 0.38, so 5 equals to 0.38 upon 0.3, so 5 equals to 1.267. You please check this. So this is the correct answer. Okay, so this is very fundamental equation, nothing else. जे आपण इक्वेशन्स आता डिस्क्राईब केली त्याच इक्वेशन्स वरती सो मेनी प्रॉब्लेम्स आहेत ते आपण व्यवस्थित त्याप्रमाणे कन्सिडर करूया. आता आणखीन एक सिंपल एक्झाम्पल घेतो आपण. द एनर्जी ऑफ एन रँडमली घेतलेली आहेत खूप सारे. हां, द एनर्जी ऑफ एन इलेक्ट्रॉन हॅव्हिंग डी ब्रॉगली than lambda, where h is Planck's constant, n is mass of an electron. What we said, we have lambda equals to h by mv. What is v? Velocity. What is lambda? De Broglie. Then what is h? Planck's constant. So equals to h upon square root of 2me. That is one of the form of de Broglie equation. We have said that. हे तीनही इक्वेशन्स आहेत ती वेव्हलेंथचीच आहेत. त्यातलं आपल्याला कुठलं इक्वेशन लागू पडतंय ते आपण उचलायचं. ठीक आहे, इथे दिलंय काय, एनर्जी दिली आहे, म्हणजे आपल्याला हे इक्वेशन लागणार. ते इथे लिहिलं, लॅम्बडा इक्वल्स टू एच अपॉन स्क्वेअर रूट ऑफ 2me. ठीक आहे, make the square on both the sides. So lambda square equals to h square upon 2me, and therefore e equals to h square upon 2m lambda square. Finished. ठीक आहे, so which is that option? Not one, this one, h square upon 2m lambda square. So this is the second. म्हणजे हे इक्वेशन जर तुम्हाला माहिती असतील आणि या गोष्टी याच्या टर्म्स ज्या आहेत त्या क्लिअर असतील तर कुठलाही प्रॉब्लेम हा अवघड नाही. द जॉब इज व्हेरी इझी. ओके, वन मोर वी कॅन सी एनी कुठलंही आपण लिहूया. ठीक आहे, when photons of energy h nu falls on a metal surface of work function omega, काही वेळेस फाय ने देतात, काही वेळेस ओमेगा देतात, डब्ल्यू म्हणतात वर्क फंक्शन. नोटेशन विथ डिफरंट. आपण लक्षात ठेवायचं आपलं नोटेशन फाय आहे, पण इथे फाय नाही वापरलेलं. ऑप्शन तरी इन टर्म्स ऑफ फाय डिफाईन नाही केलेलं. तर वर्क फंक्शनसाठी W0 वापरलाय. When photons of energy h nu falls on a metal plate of work function W0, photoelectrons of maximum kinetic energy K are ejected. If the frequency of the radiation, okay, if the frequency of radiation is doubled, जर आपण frequency double केली तर maximum kinetic energy of the ejected photoelectrons will be. These are the options. ठीक आहे, आता केस कशी आहे बघा. तर वर्क फंक्शन W असलेला टार्गेट एलिमेंट आहे, त्याच्यावरती आपण एच न्यू इतकी फोटॉन्सची एनर्जी इन्सिडेंट केली. ठीक आहे, त्यावेळेला मॅक्सिमम कायनेटिक एनर्जी के इतकी इजेक्ट झाली. ठीक आहे, आता हीच फ्रिक्वेन्सी आपण डबल केली तर मॅक्सिमम कायनेटिक एनर्जी वरती त्याचा काय इफेक्ट होतो हे त्यांना पाहिजे. ठीक आहे, व्हॉट इज आवर इक्वेशन? आवर इक्वेशन इज सिम्पली ट्राय टू रिमेंबर हाफ mv square, half mv square maximum equals to h nu minus h nu h nu 0. ठीक है, so that is a fundamental equation. What is this one? This is k. K equals to h nu, h nu minus this is what, this is the work function, and here is the work function W0. So that's why this equation is written k equals to h nu minus W0. That is our fundamental equation. Now for second case, k वरती काही इफेक्ट होतोय का हे आपल्याला बघायचंय, and k is to be replaced by k dash. So h nu, that is the original. मग आणखीन डबल केली म्हणजेच काय एच न्यू प्लस एच न्यू केला म्हणजे 2 टाइम्स एच न्यू आणि मायनस वर्क फंक्शन. ठीक आहे. सो के डॅश इक्वल्स टू के प्लस एच न्यू, के प्लस एच न्यू, because what is k? K equals to h nu minus w0. H nu minus w0. See here, h nu minus w0. What is that? K. H nu minus w0. That is k. म्हणजे इथे एक h nu शिल्लक आहे ना, तो आपण इथे टाकला की झालं, येतं ते आन्सर. So this is the correct answer. K plus h nu. Understood? One more you can see. दिसताना एक्झाम्पल खूप मोठं दिसत आहे, पण फॉर्म्युले व्यवस्थित माहीत असतील तर आपण तिथे पुढे जाऊ शकतो. नेक्स्ट, अ मेटल सरफेस इज इल्युमिनेटेड बाय लाईट ऑफ वेवलेंथ, इंटेन्सिटी अँड फ्रिक्वेन्सी टू कॉज फोटो एमिशन. म्हणजे फोटो एमिशन, फोटो इलेक्ट्रिक इफेक्ट झाला. इफ द इंटेन्सिटी ऑफ इल्युमिनेशन इज रिड्यूस टू 1/4 ऑफ इट्स ओरिजिनल व्हॅल्यू, 1/4 of its original value, then the maximum kinetic energy of the emitted photoelectrons would be. लक्षात घ्या, फोटो इलेक्ट्रिक इफेक्ट आहे आणि आपण असं म्हटलंय ऑलरेडी की कायनेटिक एनर्जीवरती इंटेन्सिटीचा काहीही इफेक्ट होत नाही. ओके, कारण हे इक्वेशन आहे आपल्याकडे, फंडामेंटल इक्वेशन, that kinetic energy 1/2 mv square maximum equals to h nu minus omega or w. W is the work function. ठीक है. So kinetic energy. So it is very clear that here is no reference of any intensity. We already discussed this fact while discussing the theory. ठीक है. So obviously इंटेन्सिटी कितीही चेंज करा, 1/4 करा, 2 करा, 4 करा, काही चेंज करा तरी त्याचा इफेक्ट हा कायनेटिक एनर्जीवरती पडत नाही. ठीक आहे. हे असे नंबर ऑफ प्रॉब्लेम्स आहेत. आता हे सिंपल आहे, हे खूप सिंपल आहे. वेळ मिळेल तसं आपण ते कव्हर करूया. ठीक आहे. त्याचे स्क्रीनशॉट तुम्ही घेऊन चेक करू शकता. स्टार्ट फ्रॉम फर्स्ट वन. हे नोट करा तुमच्याकडे, स्क्रीनशॉट घ्या आणि आन्सर करेक्ट येतं का ते फाइंड करा. येत नसेल ते विचारू शकता किंवा आपण नेक्स्ट टाइमला कॅच करू शकतो, कंटिन्यू करू शकतो. हा एक स्क्रीनशॉट सेव्ह करून ठेवा. हा दुसरा ऑलरेडी हिंट्स दिलेल्या आहेत, सॉल्व केलेल्या आहेत मी. यू जस्ट चेक इट. सेकंड, this third one, screenshot घ्या. Next, another type, अगदी फंडामेंटल इक्वेशन सेम आहे, फक्त थोडंसं रिअरेंज केलं टर्म्स, जे येतं ते आन्सर. ठीक आहे. फोर्थ, फिफ्थ वन, check this graph. Already we have discussed this graph. If incident frequency is less than, if incident frequency is less than threshold frequency, then no photoelectric current is observed. त्याच्यावरती इथे दिसते. सिक्स्थ वन, सेवन्थ आपण डिस्कस केला, एट डिस्कस केला. नाईन्थ बघा, स्क्रीनशॉट घेऊन ठेवा, चेक करा. जे येत नसेल ते माझा नंबर नोट केलात आणि पर्सनल कॉन्टॅक्ट केलात किंवा सरांच्या ग्रुपवरती जरी टाकलात, सरांना टाकलात तरी पण आपण ते सॉल्व करून घेऊ शकतो. हे सॉल्व केलं, डिफरंट मेथड्स आहेत पण आपण सॉल्व केलं. आहेत असे खूप सारे प्रॉब्लेम्स आहेत. फंडामेंटल इक्वेशन्स तीच राहतात, फक्त थोडंसं रिअरेंज करावं लागतं. तुम्ही ट्राय करा, हे खूप सारे आहेत. ओके, थँक्यू व्हेरी मच. थँक्स फॉर युअर पेशन्स.